Welcome back to the lecture series of electrical engineering. In this session, I am going to discuss most important equations which is concerning for the electrical engineering examination, especially for VTU 21 scheme, basic electrical engineering. So you can go through from module 1, you can see the basic equation of Ohm's law. You can remember the Ohm's triangle and equations of resistivity and how to compute the power. Okay, then how to calculate if two resistors are connected in series and if two resistors are connected in parallel. And voltage and current division formulas are very, very important. And you need to apply KCL and KVL. Okay, how to apply KCL and KVL? Summation of I is equal to 0 in KCL. Summation of back EMF plus voltage drop is equal to 0 in case of closed loop by considering KVL. Energy, power, and time is connected by the equation. Energy is equal to P into T, power into time. Therefore, we can calculate the total energy is equal to V into I into T. This is called as Joule's law of heating effect. Then Faraday's laws of electromagnetic induction, you can write E is equal to minus N d phi by dt. Then angular frequency and the supply frequency are related by the equations. Omega is equal to 2 pi f radian per second. And the supply frequency is inversely proportional to time period. And there is a relation between angular frequency and supply frequency by using the relation omega is equal to 2 pi f. Then you can write the general equation of AC voltage and current in this fashion. Average value can be computed by using 2 em by pi, or else you can write 0.637 em, or I average can be written as 0.637 im. This is very, very important. Then RMS value, that is equal to em by root 2, that is equal to 0.707 em. Then IRMS also can be written in the same fashion. Form factor is the ratio of RMS value to the average value, where peak factor is the ratio of maximum value to the RMS value, that is equal to 1.414. These are quite important equations you can expect in the derivation as well. Then in module 2, you have to remember about voltage across inductor. V is equal to L dA by dt. Similarly, inductive reactance, XL is equal to L omega. Capacitive circuit, you can see the Q is equal to C into V. Equation for real power, VI cos pi. Equation for reactive power, VI sin pi. Equations for apparent power, VI. Power factor can be written as the ratio of real power to the apparent power by considering the triangle. Or else you can write power factor is the ratio of resistance to the impedance. Also, you can write the impedance is the sum of square root of resistance square plus reactance square. Then RC circuit, you can write square root of R square plus XC square. Capacitive reactance equal to 1 by C omega. Similarly, for RLC series circuit, you have to remember how to write the equation for Z. Okay, the unit of Z will be ohm only. But then the power consumed in RL circuit, RC circuit, and RLC circuit is equal to VI cos pi. In case of three-phase circuit for star connection, the relationship between voltage and line voltage and phase voltage is VL is equal to root 3 V phase, IL is equal to I phase. If I talk about the delta connection, VL will be equal to V phase, where IL is equal to root 3 I phase. Calculation of three-phase power, P is equal to root 3 VL IL cos pi. In terms of phase voltage, phase quantity, I can write P is equal to 3 V phase I phase cos pi. In 2 wattmeter method, you can calculate P is equal to W1 plus W2. From this, you can compute the power factor. For cos pi is equal to cosine of tan inverse of W2 minus W1 by W1 plus W2, where W1 and W2 are the wattmeter readings of that particular method. Okay, so let us consider the remaining module. So in module 3, you can see the transformer ratio. That is the how to write the transformer ratio. Then what that in K can be represented as transformation ratio. Then the EMF equation is equal to 4.44 FIM N2. Also, you can write the equation for eddy current loss and hysteresis loss in this fashion. Then copper loss, you can compute using I1 square R1 plus I2 square R2. I1 square R1 is concerning for primary winding. I2 square R2 is concerning for secondary winding. Efficiency can be computed by using the formula. This is very, very important. V2 I2 cos phi divided by V2 I2 cos phi 2 plus WI plus WCU. This is most important. Okay, you have to remember. You can expect the numerical example as well. So if the load factor is equal to X, you can write like X VI cos phi into 10 to the power 3 divided by X VI cos phi into 10 to the power 3 plus WI plus X square WC into 100. So this is very, very simple. I'll tell you one shortcut. So you can observe here, this will be the output. Okay, output. And this is also output only. And this will be the losses. So remember this. Efficiency is equal to output divided by input. So input can be written as output plus losses. Very simple. So any clarification, please? give the comments in the comment box. I can revert. Similarly, condition for maximum efficiency, copper loss equal to iron loss. You can calculate the fraction of X by using square root of Wi by WCU. In DC generators and motor, remember the relationship between in lap winding, what will be happening? A number of conductor per parallel path equal to number of pole, where wave winding, the conductor per parallel path will be always equal to 2. EMF equation of DC generator is very important. Then you can write the EMF equation in two manner. Please go through this. In DC motor, the force developed by the conductor is given by F is equal to B into I into L. Back EMF can be written as two fashion you can write. EB is equal to V minus IARA, EB is equal to 5 by 60 into P by A. Then armature torque, that is very important, 0.159 IA P Z by A. This is most important equation. In module for synchronous generator, you have to write one important equation, synchronous speed, that is equal to Ns equal to 120 F by P. EMF equation can be written as 4.44 F into T phase, TPH, KP into K. Okay, so there is a relationship between T phase and conductor, number of conductors, that also you have to remember. In induction motor, the resultant flux is equal to 1.5 into maximum flux. So double what we can expect is how to come the working. The working can be explained by using this equation. The slip speed is equal to Ns minus N. In slip can be written as Ns minus N divided by Ns. Ns is the synchronous speed, N is the actual speed. Frequency of induced EMF in the rotor is equal to F dash equal to S into F. In the last module, two-part tariff equation is very important. It comprises of fixed cost and running cost. So this will be the fixed cost. Look at this. So let me explain that. This is called fixed cost and this part is called running cost. So total unit generated per year can be written as maximum demand into load factor into hours in a year. Load factor is nothing but average load by maximum demand. So these are the most important equation. I request everybody to note down. A few more remain. Okay, these are the important equations. All 5 modules you'll be getting some derivation as well as numerical example. So kindly apply this and have a good score. So I wish you all the very best for your examination. Thank you for watching this video.